Okay, algebra students, Mr. Fovel's back with lesson 712. And this lesson is going to focus on what we call completing the square. Now this is another way to work with quadratics. What we're going to do is we're going to look at what can be added into a standard form quadratic so that we can create vertex form or solve a quadratic. So what I have is just an example of the thought process that is going to go through our head. But the great thing about this is this one actually allows us to kind of do everything in our head. We probably don't need to draw out the area model all the time. So one of the things that is important here is this is going to be working with a square. And we know one important thing about a square: the sides are equal. And because they're equal, that actually makes our life a little bit simpler in this situation. So we have x squared, which will be this top box here. Well, how do we get x squared? We get it from x times x. Very simple. Okay, now we need to look at our 8x. Well, because it's a square, we have to break that 8x equally into these two boxes here. So we're going to have 4x in this one and 4x in this one, which means that we have an x times something gives us 4x. Well, the only thing that could be is 4. And we have x times something gives us 4x. So this has to be 4. So our problem is x plus 4 times x plus 4. Well, the only missing part here is this box right here. We'd have 4 times 4, which should be 16. But if you notice in our original problem, there's no 16. So this is called completing the square because we are going to add that 16 into this problem. And now we have created a quadratic that is a perfect square. And we're going to use that idea within these two problems. So the first thing I'm going to show you is how we can use this thought process to solve an equation. So if you notice, we did have an x squared and an x, but we didn't have anything here. So we're actually going to get rid of the 40, and we're going to add 40 to both sides to create x squared plus 6x, and then we're going to have this missing number and 40 on the other side because these create 0. We want to add something here to create our perfect square. Well, if you remember, we just took the 8x and split it in half. So the 6x just has to get split in half to make two 3x's. Well, x times 3 makes 3x. So we're going to be using x plus 3 and x plus 3. Notice I could do that thinking without drawing the whole picture. Well, the important part here is what gets added on. Well, here we did 4 times 4 gave us 16. So here we're going to do 3 times 3 gives us 9. So we're actually going to add 9. And because we added on one side, we have to add it on the other side. Here's the thing though. This right here is the same as this. But there's an even better way of writing it. Because it's a square, we can write it with that exponent of 2. So we're going to write this problem as x plus 3 squared equals, we're going to add these together and make 49. And now we create a situation that is going to be really simple to solve. We have a square here. The opposite is 2 square root. So we're going to square root both sides. Thing is, when you square root, that gives you two answers. It gives you a negative and a positive. So 49 can be both negative 7 and positive 7. So we're going to create x plus 3 equals negative 7, and x plus 3 equals positive 7 because both of those are possible answers. Then all we have to do is do basic algebra and subtract 3 on both sides. We want to keep it equal. X is negative 10. And we want to do the exact same thing here. Minus 3 on both sides. X is 4. So what this is saying is both negative 10 and positive 4 could be put in for x to make this problem work. All right, now the other situation is if we want to write this in vertex form to possibly find the vertex. Well, what we do in this situation is, again, we want to have a blank canvas over here. We want to get rid of our 2. So we're going to minus the 2 on both sides. The difference here is, in this one, we could add 0 and 40. We can't do y minus 2. So we're literally just going to write it y minus 2 equals x squared minus 10x. Okay, and then we're looking for what's going to be added on at the end here. So we want to know what to add. And then we're going to have to add it on both sides, essentially. The difference here is this one's now negative 10, where the other two were positives. That shouldn't actually change anything. What we do is we are actually going to use x minus 5 and x minus 5. The only difference here is we're using the minus sign instead of the addition sign. But a negative 5 and a negative 5 will still give us a positive number, so it shouldn't change anything. So 5 times 5 gives us 25. So we're going to get 25 here and 25 here. And then we're going to rewrite the problem. Y plus 23, because negative 2 and 25 make 23, equals, well, we want to use our square version of this. X minus 5. We're going to square x minus 5 squared. Okay, we want this in vertex form. Well, it's close, but it's not quite there. What we want to do is we want to move the 23 to the correct side. So here it says add. We're going to subtract 23 on both sides. And that's going to leave us with vertex form y equals x minus 5 squared minus 23. So this is now in vertex form. And if we need to, we can figure out that the vertex is 5, negative 23. Because if you remember, 5 creates this being a 0, and this stays exactly how it says. All right, this is a little bit longer video. This is a little bit more in-depth stuff. So I would expect, as you're taking notes and things, to possibly have to rewatch this video, rewind it if necessary. Please come to me with any questions that you have. Thank you.